let's take a look at this particular problem in the sense that the end of chapter 3, section 3.3, instead of ask you to construct the truth table, instead of ask you to construct the truth table and find the end product, they give you this truth table and they ask you to fill in the missing value, right? The missing link. So in order for you to do this truth table or to finish this particular truth table, you have to know the exact criteria of each item, right? And this item I mentioned last Thursday is like you work your way through the puzzle, right? You try to find what you know and find the missing item. So for this particular truth table, we have to fill in this true value for this 3 missing item. And like I mentioned, to find a negation is the easiest thing to do. If there's a negation, that's the easiest thing to do, because the negation of C is basically telling you what is the value for C here. The value for C is true, then the negation is just false, right? So the negation is the easiest thing. Just look at the individual column and then ask yourself the opposite of that column. And once we have this thing, it does not relate to this item, but we can find this item because they ask you A or B, right? The disjunction of A or B in this case. So what is the criteria of or? The criteria of or, reminder, the criteria of or for me is if there is a true, as long as I see a true between A and B, as long as I see a true, the result will be true. Doesn't matter which one, right? I'm only looking at, and you know, if you want to be safe, you block the thing that you don't need, right? So for this particular item, I'm looking at A or B. So between A or B, I know that the criteria for or is as long as there's a true, the result is true. So once I have that, now do you agree that this item here, is the or criteria? The or criteria, I mean the and criteria, the upside down V is the and criteria. And what am I looking? Why is my result is false? Well, the and criteria tell me is as long as one of them is false, for me, as long as one of them is false, the result is false. So I'm looking for my parenthesis right here, and the negation of C. The negation of C is here. So between these two items, as long one of them is false, the result is false. So in the sense of this particular true value or true table, they don't ask you to fulfill one slot to the next. They just ask you, if you look at this particular item, can you dissect or can you use your criteria to find the missing link, right? So for this particular item, we cannot find this particular link, right? So they give us the B, they give us the C, they give us the A and B. So in order to do this problem, you have to know your notation. And then on top of that, you have to know the criteria of each notation. And similarly to the top one, we can find the negation of C very easily, because whatever C is, the negation of C tell me that the opposite. So in this case, the C is false. The negation of C will be true. And now, we cannot find this without, well, we can find this without finding A. But how do we find A? If you remember, or let's take a look, or let's ask you this question. This is A and B. And remember, A and B is true. When does A and B is true, or when does the and criteria is true?
When both of them are true.
Both of them are true. And if I know B is true, what A got to be? Well, in order to be true, both of them have to be true. If B is true, then the A got to be true in order for your and statement to be true. And that's what we need to do, is we need to use in that criteria to find A. And lastly, looking at this item here, we have to look at the parenthesis, but doesn't matter which parenthesis we're looking at. we can see that this parenthesis A and B implies C. We know that both of them are true. The result is true, right? So in the sense, this is what you guys need to do to fill in the missing value. Is you need to know your criteria by heart, right? You need to know your criteria. When does the and is false, or when does the or is true, or vice versa. So question in terms of the first two items we have here, in terms of the first two true table that we need to fill in. And this
does false, when you say imply, the arrow for the implies button, when is it false?
The only time, or the one time, that the error is false is the first thing is true, imply the second one is false. This is the one and only time that is false. If it's not this sequence, if it's not this pattern, then it's true.
Okay, so it can, but so it can be
it can be anything else, it's gonna be true.
Okay, so it can be false implies true.
Right.
Then it's true.
Yes.
Okay.
So anything else is true. If the first thing is false, it's automatically true. That's how I remember it. If the first thing is false, it's automatically true. And again, if the first thing is false, it's automatically true. The only time it's false is the first thing is false and the second one is true. Okay. Or some other student, this is what they tell me, or this is what they say, is if the first thing is true, if you don't remember the sequence, if you don't remember the sequence, this is what the other students say, that if the first thing is true, the second item determines the result. If the first thing is true, the second item is false, the result is false. First thing is true, the second item is true, the result is true. First thing is false, automatically true. We don't care about the second one. So we only care about the second item if the first item is true. Okay. But again, you can remember that this is the only time that is false. Everything else that is not follow this pattern is true. That's fine. Right. So either way. Okay. Any other question? Well, let's take a look at this a little bit massive problem, a little bit more missing link. So same idea, right? Looking at this item, we can find, hopefully you guys can find B, right? We can find B because B, if the negation of B is true, we know that B will be false, right? Everybody see that for this item, we can identify, or we can find B, and we can find the negation of C easily, right? Because if we know the negation of B, the B will be the opposite of that, which is if the negation is true, the opposite will be false, or vice versa. And if C is false, the negation of C will be true. So we can see that we got half of the item, we have half of the item done. Agree?
Yeah.
And now, what is the if and only if criteria? Double arrow. Well, double arrow tell me that in order for the double arrow to be true, because this is what they tell me, that this right here is true, in order that to be true, do you agree that they have to have the same true value? They will be either both true to be true or both false to be true. And because I know that this is true, the A have to be true in order for this item to be true. Everybody see the connection? Everybody see the connection here? In order for the if and only if, in order for the double arrow to be true, the only reason in order for the double arrow to be true, they need to have the same true value. They either have to be both true or both false. And because I know that this is true, A got to be true, because A and not C have to be true in order for the if and only if to be true. Everybody see the connection there?
Yeah.
And once you see that connection, now what do we have? They tell us that we need to look at, what do I need to look at? I don't care about this item here. I don't care anything else. but this 2. I need the parenthesis A if and only if negation of C imply negation of B. And again, 2 of the true would never be false, right? Everybody see? 2 of the true will never be false, so this result here is true. Unless you take the negation of it, but 2 of the true will never be false. So again, question here in terms of this particular item, you know, and one thing is, if you like puzzle, right? If you like puzzle, if you like analyze and stuff, this is what we have. This is basically the math in chapter 3 is a lot of analyze your problem. So question in terms of this particular truth table, how to find the missing link. And lastly, you know, looking at this thing here, we can do a few things, but let's take the obvious, right? Take the obvious. If you look at this thing here, there's no way we can do this item now because we don't have the negation of all. But do you agree that we can find the negation of all? The negation of all is whatever all, the negation will be. The negation will be true. And we can find the Q, which is this item, and this item is similar. The negation of Q is false. We know the Q will be true. So do you agree that those 2 items I can find, or you guys can find it easily with those?
Yeah.
And now, if the negation of Q is false, and the connector here is the OR criteria. Remember, the AND criteria is they need to be both true to be true. And now if this is the OR criteria, what does the OR criteria say? Well, in order to be false, the OR criteria, both of them have to be false in order for the OR criteria to be false, right?
I'm about to pull up the,
analyze,
we got 2 Hyundai payments and we got a Geico payment that we've been waiting on. So
can you?
that's because we've been calling them. That's why. Hey. We've been calling, blowing up them people's phones.
Who's that? Can you mute your mic, please?
Again, make sure if you have your mic on, please mute your mic unless you have a question, please. Again, if you look at this item here, go back to this. Remember the OR criteria, in order for the OR statement to be false, both of them have to be false. And that's why I can come up with this false item right here, okay? Because they give me the one item they give me is a, the one item they give me is this item here. They give me the negation of Q, and the negation of Q is false. And reminder, in order to be false, both of them have to be false. And that's why I can come up with this false, because of the OR statement. The OR statement is both of them is false. The OR statement is false. So in the sense of this particular problem, that's what you need to do, is you need to see what is the connection between the missing item that you have. And the connection of this 2 is easy, right? The connection of this item and this item is easy because it's just the opposite of what they give you. But now you have to dig deeper to find a B. The negation, or not the negation of Q is false in order for the OR statement to be false. In order for the OR statement to be false, both of them is false. And that's why the P is also false. And looking at this item, and if you in doubt, right? If you in doubt, just block what you don't need out, right? So this is my connector, is the if and then statement. I'm looking at my parenthesis, which is my parenthesis is this column here, and I'm looking for negation of all, which is this column here. Reminder, at each column, at each connector, the main thing, or not the main thing, you only look at 2 columns at most. And this connector is the if and only if. And what is the criteria for if and only if? Well, the criteria for if and only if is they need to have the same value. In order to be true, they need to be the same. In this case, they are not. And if they are not the same, they are false. I changed the notation. This is supposed to be false, guy. It's not true. Again, they are not the same. They are not the same. It's supposed to be false. So the result here is false. It's not true. Okay. So that's the typo right there. So question here in terms of this particular item. Question in terms of this particular item here that we have.
Professor, so when the and statements are true when one of the truth values are true.
No.
No.
The and statement is true if only when both of them are true.
When both, okay. And the or statements are true
When one of them is true.
When one of them is true. Okay. Gotcha.
Any other question? We will get to do more truth table in a bit, but if you don't have question with this one here, and like I said, last time I tried to go over this so that over the weekend you see it, you know how to do it, and then all of a sudden my computer got froze. But again, hopefully you guys are able to see those. But if you don't have question, let's take a look at 3.4. So 3.4 is the last section we have, and in 3.4 we are dealing with a logical argument. But before we deal with logical argument, I think you will run across this item first in terms that they ask you, how can you translate the statement? How can you translate a statement involve 3 letters, involve 3 simple statements? So if you remember in the beginning of this chapter 3, we talking about a compound statement. And whenever we talked earlier, we only compound 2 items together. We say, today is Monday, I have to go to work, right? If today is Monday, then I will stuck in traffic or something in that nature in terms that we only connect 2 items. What happens if we connect 3 items together? What happens if we have P, Q, and R? Well, one thing about P, Q, and R, do you agree that they give you the P, Q, and R, and they connect the 3 items together, which our connector is the AND connector and the if and only if connector. So your goal for this particular item, your goal is how can you take this English statement and convert to symbolic? And just like before, whatever you see, you write it down, right? So for A, do you agree that the weather is cold, which is that is my Q, the weather is cold, and which is the upside down V, the traffic is bad. What is related to the traffic is bad, my R. If and only if, do you agree that the if and only if is the double arrow? It is a fall season, which is fall season is P. So again, one thing is a lot of students, they overthink and they try to say, oh, is this statement a true statement, or is this a statement a false statement, or this statement does not make sense? One thing is they don't care about the nature of the statement. They want to test you to see if you can take the English and translate to the symbolic. Yes, the English statement might not be true or might not make sense, but we are not trying to make sense. We try to make a logic in terms of we try to convert to a symbolic. And that's why we convert to symbolic, because symbolic does not tell you the statement is making sense or common sense or something like that. It just tells you PQ and all, right? So you probably say, so what is the difference between this problem versus any of the other one? Well, one thing is if you have 3, or if you connect 3 items with the 3 operation, they have to contain a parenthesis. Meaning we cannot just put it this way and let it slide, in the sense that there is a small rule of comma. So the small group of comma is if your English statement have a comma. If your English statement have a comma, you need to translate that comma to a parenthesis. So basically, everybody see that my comma separate the and statement. Because my comma separate the and statement, what do they separate or what do they group them together? They group the weather is cold and the traffic is bad together. And because they group it together, you need to illustrate that there is some grouping in for, which is you need to illustrate them by put them in a parenthesis. So that's the only thing new in terms of you translate three variable is because there are three variable or because they connect two connector, you need to show which one is the main connector or which one is the grouping. And to show the grouping is basically if your statement have a comma, you need to group whatever the comma separated. Okay, so everybody see the comma is right here. It separate the if and only if, meaning the if only if it's on the outside. We grouping this two together, which is Q and or. What is Q and all? Q and all is the weather is cold and the traffic is bad. If and only if it is a fall season. So that's the only thing new here is we need to emphasize the comma and illustrate that to your parenthesis or in your grouping item. Okay. So let's try another one and then I will ask you guys if you have questions. Let's take a look at B. If it is not fall season, then the weather is not cold or the traffic is bad. So same idea go, you can see that if it is not a fall season, so you see that P is fall season. What is the difference? Well, if it's not, we put in the negation of P, right? My P, it is fall season. Right here, it is not fall season, therefore the negation of P. Then, if you remember if and then, this is my symbolic for if and then. The weather is not cold. What is the weather? Q is related to my weather, but my weather here is cold and out here is not cold. I have to put in the negation of Q. Or, which is the right side V, the traffic is bad, which is my or. So everybody see that the connector is the if and then connector and the or connector. And the only reason why I have a squiggly line or a tilde is because of the negation, because of the not, is the opposite of my original statement. My original statement, I identify or Alex, they will identify for you. This is your original statement. If anything is not, if anything that have the word not, meaning is the negation of this, okay? Now, where is my parenthesis? My parenthesis is here. Do you see that they group this two together, right? They group this back and this two together, which is my or statement. They group the or statement together. So how do I illustrate the grouping? I just put the parenthesis in the back because they group the or together. So if it is not for, then the weather is not cold or the traffic is bad. So this is the only thing new dealing with the three statement connector. If you connect more than two statements, we need to group them together. In this case, for us, the rule of group them is your parenthesis. I mean, your comma. So if you have a comma, you need to insert the parenthesis. You just ask yourself, what does the comma separate it? Wherever the comma separated, that is what I want to group them in. So before we do C, question with A or B, question of how I translate from the English, put it in a symbolic, and why or how did I group them together? So if you don't have question with A or B, well, let's take a look at C. Same thing go, right? What relate to traffic? Well, traffic is my all. My all is the traffic is bad. The only thing down here is the traffic is not bad, meaning the negation of all. And all will be the right side V. The weather is not cold. What is the relate to the weather? The weather is my Q, but in this case, because it's not, so I put in the negation of Q. And which is the upside down V, it is fall season, which is my P. So everybody see how that I took this wording, right? Take each single word, each connector, and again, make sure you know what the connector is, right? Your connector is this item right here, the or, the and, the if and only if, and the if and then. Okay, so again, those are your connector. Everything else is just your statement. Everything else relate to your P, Q, or O. So in this case, what do I connect? What do I separate? Do you agree that I separate the first item, which is my O, outside from my second two item, which is I need to group the and together. Okay, so again, I separate the first item by itself. I do not put the, one thing is do not put the parenthesis include the or too, right? You cannot include the or with the parenthesis. You only include two variable, don't include two operation. If you include two operation, you need to have another bracket or something. But for now, just ask yourself, what is the separator? And whatever the separator is, I need to put them in the parenthesis. So question with C, question of why or how I have the parenthesis in the back and where my connector come from. And again, hopefully by now, translation is you know, you guys can translate it easy. The only thing new that they imply or they want to show you is the comma, right? Because connect multiple item, more than two item, I should say, we need to, you know, grammar to be to have a right mechanic, we have to have a comma, and to translate from comma in English to our math, we just need a parenthesis. Okay, so if you take a look at D, they say if the weather is cold, then it is fall season, if and only if the traffic is not bad. So first of all, we know that the connector, our connector, the two connector we have is the if and only if, that's one connector, that's a double arrow. And if they start with the if and then, we know that we have a single arrow. And to translate this thing here, we know that we have the weather is cold, that is your Q. If and then, which is your single arrow, it is a fall season, which is your P, if and only if the double arrow and the traffic is not bad, which is negation of all. So everybody see that the translation take the D English statement and convert that to symbolic, which is Q, single arrow P, double arrow negation of all. But we cannot just leave it like that. We have to ask ourselves, what does the comma separate? Do you agree that they separate the back two, right? They combine the back two together. So if the weather is cold, then it is a fall season if and only if the traffic is not bad. So those two items, the traffic have to be not bad and it's a fall season in order for the weather to be cold. And again, like I said, we are not looking for the making sense of the statement. We making in terms of how can you convert the English statement to your symbolic. If you look at D, if you glance through D and glance to E, they are literally the same exact word for word exact statement. So look at this thing here, D and E, if you look at it, they are exactly the same word per word. So if you translate them, it's just the same as the previous item without the parenthesis, right? So if the weather is cold, then it is fall season, if and only if the traffic is not bad. Literally identically is the same. But the problem comes, ladies and gentlemen, and the purpose of me giving you this particular item is, where does your parenthesis fall under, or where does the comma separate? Do you agree that the comma separate the if and then? Meaning the if and then is not in your parenthesis. So what is in your parenthesis? We need to group the if. I'm sorry, the if and only if is not in your parenthesis. So we have to group the if and then, right? The if and then, that is your first item. So we have to group the first two items, not the second two items, okay? So just because of the comma position, we need to shift our parenthesis. And if you were to do the truth table, they will be different, okay? It's not the same, it's not equivalent. But question here in terms of how do we take this wording, down here and translate to the symbolic? And vice versa, they might ask you, if they give you the symbolic and convert, choose the right wording, you know, and you have to make that connection. But question here in terms of this particular example, how to convert from English to symbolic. Any question at all? All right, if you don't have question, let's take a look at 3.4. So again, the previous one is basically kind of review so that you know when you look at the argument, you can translate them. Because in 3.4, ladies and gentlemen, argument, basically, just like in 2.4 or in chapter 2, when you do the survey question, 3.4, the argument question is basically, they combine everything that you learn and put them together. Meaning you need to know the truth table, you need to know your symbolic, and you need to know how to translate them. So before we do all that, let's take a look at what is the argument for us. So the argument for us is we have either a valid argument or a fallacy, meaning an invalid argument. And for us, our argument make up by two items. We have the premise or premises, and based on that premises, we will have a conclusion, okay? And for our argument, in order for the argument to be a valid argument, the conclusion have to be all true. Meaning if it's tautology, then it's a valid argument. If it's not a tautology, then it's a fallacy, which is a invalid argument, okay? So how do we know if it's a tautology? Then the only thing is we need to know is we have to construct the truth table. So if the truth table come out to be all true, then it's a tautology. And if it's a tautology, we have another name, which is now we just say that is a valid argument. And like I mentioned, in terms of the logic here, we are not trying to prove something is true or something is false. We are trying to see if we were to give this condition, if we were to give this premise, can we take the premise and convert or to verify if the conclusion followed those premises, okay? So let's take a look at this item here. In terms of how do we determine your argument is valid or fallacy or invalid? So here come the 4 steps. This is the 4th step, and Alex is good for you guys in terms that Alex lists out each step for you guys. So the first step to know if your argument is valid or not, the first step is we need to translate your argument to symbolic. That's what we just did earlier. All you will see is you will see an English statement, and then from the English statement, you put them or translate them into symbolic. And then once you have a symbolic, basically you put in this formula. And the formula is basically your premise 1 and premise 2 imply your conclusion, okay? And the imply or the double arrow that you see on your screen right there is just the same as the single arrow. The only thing they change is they want to make sure that you recognize that this is a argument item and not the implication. It's just a small difference. It's not anything special. Okay. So after you plug into the formula, and I will mention the formula in a bit later, but after you plug in the formula, now we need to construct the truth table. We need to construct the truth table, and if your truth table, this is your formula, ladies and gentlemen, your premise 1 and premise 2 imply the conclusion. So the and, if you look at this item, you say, wait, why is blue ink? Well, the blue ink for step 2, the blue ink is fixed. Those blue ink will never change. Okay, those 2 blue ink will never change. Basically, this is your formula. You have the first premise and the second premise imply your conclusion. So the 2 blue ink will never change. That will be your formula. Okay, and once you set up this item, now all you do is you need to construct your truth table. Your truth table, if your last column is a tautology, which is I mentioned earlier, all true, then it's a valid argument. If it's not a tautology, then it's an invalid argument. It have to be tautology or nothing at all. Okay, so either all true, a tautology, then that will be your valid argument. If it's not valid, this will be invalid. Okay, so I know if you look at this slide, if you look at this step, you say, wow, that's a lot of steps. But it takes practice, right? Let's take a look at this example, and you will see that by the third example is very redundant, it's very repetition. So let's say if I give you this argument here, I give you this argument. So the argument is this. The argument is if John is at Disney World, then John is wearing a Mickey shirt. John is not wearing a Mickey shirt, therefore John is not at Disney World. So first of all, you probably say, well, what does this 3 dot mean? Well, this 3 dot is just say therefore or in conclusion. Don't worry about this 3 dot. There's not. It basically tell you that this is your premise 1, this is your premise 2, and this is your conclusion. This 3 dot is just say therefore or in conclusion. So they give you the P, they give you the Q, so they good for you guys. They identify the P, they identify the Q for you guys. Now they ask you, if John is at Disney World, then John is wearing a Mickey shirt. If John is not wearing a Mickey shirt, therefore John is not at Disney World. So if you remember step 1, they tell you to identify or take this argument and translate to symbolic. So we know this item here, ladies and gentlemen, we know that we have premise 1, premise 2, and this is our conclusion. And the good thing, the good news for you guys is this is the setup that they have. You will have the first sentence, and your first sentence is your premise 1. You will have a second sentence, and your second sentence is your premise 2. And you will have a therefore or in conclusion, which is your conclusion, which is your third sentence. Okay, so what do we need to do? Well, we need to take this wording. We need to take this word and translate to symbolic. Can you translate if John is at Disney World, then John is wearing a Mickey shirt? How do we translate this? Well, we know that what is related to John and Disney, which is P. So do you agree that this is P, error Q? Because this is my P, John is at Disney World, that's related to my P statement, John is at Disney World. John is wearing a Mickey shirt, which is John is wearing Mickey shirt. So my P, my Q, and they connect by the word if and then, which is the if and then is one single arrow to the right. So that's my premise 1, that's my first line. My first line tell me that P, error Q. And what does my second line, what does my premise 2 tell me? Well, premise 2 tell me that John is not wearing a Mickey shirt. So Mickey shirt relate to Q, and he is not wearing it, which is, do you agree that is the negation of Q? John is not wearing Mickey shirt, which is negation of Q. And in conclusion, or therefore, John is not at Disney World. Do you agree that anything related to Disney World is my P? And John is not at Disney World, which is negation of P. So that's the first step, ladies and gentlemen. Is it new? It's not quite, right? The presentation, the present of the problem is new because now they put it in this structure. They put in the first line, the second line, and the third line. They put in this structure, but you know, what have we been done? What have we been doing? We just translate them, right? We just take the word, we take this word, whatever this word is, and we translate to the symbolic that we have over here. So question here in terms of step 1, that we need to take the word and translate to symbolic. Now, step 2 is basically step 2 and step 3 is kind of the same. Step 2 is basically tell you that take that item that you just translated. Don't care about the English item anymore. Take the symbolic that you have and put them in this formula. And like I mentioned to you guys, the formula is this. The formula is the first item. The first premise, do you agree that my first premise is P arrow Q? That's my first premise right here, P arrow Q. And which is, that is your formula. This will always be here. This blue ink will always be here. Premise 2, which is the negation of Q, imply, which is one single error. This 2 item is the same, negation of P. So this is what we have, ladies and gentlemen, that we take this 3 line and we put the first line first and the second line imply the conclusion. The blue ink, I kept on mentioning, the blue ink is fixed. It will always be the same. We want to keep consistent. This blue ink will always be the same. All you do is fill in, just imagine that you have 3 blank. You have the first blank, that's your first line. You have a second blank, that's your second line, and you have a third blank, that's your third line. Everybody see the first line, second line, and third line. Everybody still with me here? I take the English, I translate to symbolic. I take the symbolic and I put it basically, if you want to connect to the item we have before, just imagine that you have 3 empty boxes. Blink, the blue item is fixed. The blue item will never change. You have 3 empty boxes. You need to fill in this 3 empty boxes. How do you do it? You take the first item. The first item you put in the first box. The second item you put in the second box, and the third item you put in the third box. So that's where my 3 items came from. Now, the only thing that we have is, if you see this thing here, just like before, we have multiple connector. And if we have multiple connector, we need to group them up. And to group them up, basically they tell you that you need to group the first 2, imply your conclusion. Is the first item, and it's always be the same, it's basically the premise 1 and the premise 2 imply the conclusion. So you need to box, or basically in here, I don't want to put a parenthesis because I already used the parenthesis here. So I have to use a bracket just to show you that we need to do the parenthesis first, and then we need to do the bracket afterward, okay? And I think Alex is good for you guys, because if you fill in your premise, because I think Alex, if you fill in your premise 1, you fill in your premise 2, you fill in your conclusion, they automatically type it in the formula for you. And that's the one thing that I saw on Alex that is on with your, going with your benefit in terms of that, because they fill in the item for you. They automatically fill in this 3 box for you, okay? So questions so far in terms of translate and put in the formula, because the next item is just the same thing that you had before. because how do I know if it's a valid argument? Well, to know if it's a valid argument, I need to construct the truth table of this item here. So basically the same formula that I have in that box is right here, and I need to construct the truth table. And just like before, do you agree that construct any truth table, my starter kit is my P, true, true, false, false. My Q is true, false, true, false. So looking at this item, we know that we need to work inside the parenthesis first, and inside your parenthesis is P arrow Q. And P arrow Q, we got the P, we got the Q, and P arrow Q reminder. What is P arrow Q? P arrow Q is the only time that is false. The only time that is false is the first item is true and the second item is false. Everywhere else is true. If it's not the first item is true and the second item is false, then it will be true. The only time that is false is the first item is true, arrow, the second item is false. Everybody see that that is why this item is false. And similarly, like before, I need to do the and statement, and that's why the grouping is coming in. I need to do the and statement, but before I can do the and statement, I'm missing the negation of Q. And the negation of Q, hopefully you guys say, it's easy. The negation of Q is false, true, because whatever my Q is, I take the opposite, which is false, true, false, true. So I got the two item I needed. What is the two item I needed? This is the two item I needed. I need the parenthesis and the negation of Q. So do you agree that my parenthesis is here and the negation of Q is here? And when does the and criteria, when does the and statement is true, or when does the and statement is false? If you want to remember, if earlier I say that in order to be true, the and statement, they have to be both true. That's the and statement, they got to be both true. Or if the other way for me is as long as there's a false for the and statement, as long as there's a false, the result is false. So we can see that there's a false in the first three, and this is the true. So doesn't matter how you want to remember it, but you have to remember it. That's the challenge. You need to know your criteria and you need to know your symbolic. Both of them is true, and the result is true for the and if you want to remember it that way. If not, you can say that as long as there's a false, the result for the and statement is false. So pick one or the other, whichever you feel comfortable. That's how you want to remember it. Don't mix and match. Okay. So everybody see so far question with this truth table so far, and this is the fourth time or the third time we're doing it. Hopefully you have the hang of it. If you don't, stop me here because you have a test this weekend. So question so far here.
So Mr. Trang, you only put the premises under the brackets and you don't put the collusion?
Yeah, you just put the premise in the bracket. The conclusion is by itself.
Okay.
And if you do an Alex, once you fill in the premises, once you fill in the first premise and the second premise and the conclusion, Alex automatically put in this formula for you. So in Alex, you will see that automatically they have the truth table, they fill it in for you, and then you have to construct the truth table. But yes, if you do it by hand, if you do it, yes, only the first two premise you group them by a bracket. Yes. And to finish this item, what am I missing? Do you agree that I have my bracket, which is my bracket is here? I'm missing the negation of P. And the negation of P, once again, very doable, very easy. Whatever P is, I just take the opposite. Agree? And once we have that, we can finish the whole thing. And to finish the whole thing, again, You don't need to, but it's easier to block out what you don't need, right? What do I need? I need the parenthesis, my bracket. My bracket is right here. Whatever in my bracket is this item. And I need the negation of P, which is whatever the negation of P is this. And the only time that I am worried, the only time I'm worried about this error, right? Because of this item right here, this is my connector, is the if and then statement. The only reason the only time I worry about the error is the first thing is true. And if the first thing is true and the second thing is true, we know that this is true, right? Remember your error, if the first thing is false, it's automatically true. If the first thing is false, it's automatically true. If the first thing is false, it's automatically true. If the first thing is true, we need to look at the second one. First thing is true, second one is true. This is true. Okay, so looking at this thing here, everybody see that my final product, and again, I would erase this a little bit, but my final product is that they asked me to construct the truth table for this item, and I got the truth table for that item for them. And this truth table, hopefully you guys say that this is a tautology because it's considered all true, so it's a tautology. And if this is a tautology, then we know that it's a new term, is a valid argument. That is all. If you construct your truth table and the final product is a tautology, all true, consider all true, then we say that new item, we say that is a valid argument. If it's not a tautology, then it's an invalid argument. So looking at this thing here, this is what you need to have. Like I mentioned to you guys, on Alex, they only need the final product. They don't even grade any of this thing here. They give you this PQ and they ask you to come up with this final product. And that's why, you know, last week and last Thursday, I mentioned that to help your eye a little bit, just do it on your piece of paper and then just type the final product in, okay? But question in terms of this truth table. So just to reminder, right, just to refresh what we do. First, we need to translate the English to symbolic. We need to translate this item from English to symbolic. Once we translate the English to symbolic, we need to plug into the formula. Once we got the formula, we construct the truth table. And once we construct the truth table, if it's a tautology, it will be a valid. If it's not tautology, it will be an invalid argument. So let's take a look at example 2. Let's do example 2 together and show you guys the consistency or the redundant or repetition of this particular argument. So they give you P, John is at Disney World, same P as before. Q, John is having fun. So again, so those are your two items. Now this is your argument. We need to translate, we need to use the P. We need to use the P and the Q here and take and translate this wording to symbolic. Everybody see the first step. So if John is at Disney World, we can see that John Disney World, which is, that is your P. Then John have fun, which is the same as before, P imply Q. It's just that my Q is different now. Last time Q is John wearing a Mickey Mouse, shirt, right? This one here, John is having fun, which is Q. And what is John having fun? Well, John having fun is just Q by itself. John, therefore, what is the conclusion? The conclusion is John is at Disney World. So if John is at Disney World, John having fun, John is having fun, therefore, in conclusion, John is at Disney World. So everybody see how we take the word, the English, and translate to symbolic. And now, once we have the English in symbolic, or once we have the symbolic basic reminder, we just have this 3 box, right? We take this 3 item, and we fill in this formula. we fill in the and we fill in that item. Like I mentioned, this two blue item, the two blue item is fixed. The two blue item is fixed. We just take the first box and we put it first. We take the second box, we put it second, and we take the third box and we put it third. Everybody see that that is your formula that you need. We take the first box, we put there, take the second, and we take the third. So all we do is we translate and then we fill in here. And like I say, if you did the homework, if you did the Alex Pie, they fill it in for you. But question in terms of the first step, translate from word to symbolic, taking all this English writing and trying to translate to the symbolic writing there. And the question of how to take the symbolic and put it in your formula. And if you don't have question with those two, the only thing left we need to do is we need to construct the truth table. So if we construct this truth table, let's take a look at this item. Construct this truth table similar to before. We need to have the P, the Q, and we can do this item, and this item is just the same as before. The only time that is false, is the first thing is true and the second thing is false. So this is false. When the first thing is true, imply the second thing is false. Now, everybody agree that true, false, true, true? And we can finish the bracket, right? We can do this operation. We can do the and. We got the two items we needed. What is the two item we needed? Well, the two item we needed is not Q, not P, right? We don't need P. We need a Q, and we need we need a Q, and we need a parenthesis. So the criteria for and, this is the and statement. The criteria for and is as long as there's a false. For me, as long as there's a false, doesn't matter where, as long as there's a false, that row will be false. I don't see a false here, so this is true. I see a false here, this is false. I don't see a false here, this is true. I see a false here, this is false. So again, the and statement, you can think in terms my way, as long as there's a false, the result is false. Or you can think in the book ways, the only time that is true is when both of them are true. It's up to you. It's how you make it easy on yourself to remember, right? The only time that is true for the and statement is when both of them are true. If you want to think it that way, be my guest. If you think it in terms of my way, if it's easier, use it. If it's harder, don't use it, right? So question here in terms of how I got so far this truth table. And hopefully you guys see that we are not done, right? We just did this part. We just did the parenthesis, bracket, which is whatever the bracket is, that's what the column I have. To finish everything, we need to, for me, like I say, you don't have to, but for me, because of the order matter, whatever on the left, I want to look on the left, and whatever on the right, I look on the right. So for me, I just move this P to that side so that it's easy on my eye. I don't have to look all across the board, and maybe I look at the wrong column. So for me, whatever on the left, I have on the left, whatever on the right, I put on the right. You don't have to if you don't want to put it there. But everybody see that I got the two things I needed to construct the final item. And the final item, if you remember, the only time that is false is the first thing is true and the second thing is false. If the first thing is true and the second thing is true, that is still true. The first thing is false, is automatically true. This is the one and only time that is false, is the first thing is true, imply the second one is false. And now the only thing left is this, right? I don't care about this item here. I need this step to get to my final product. And now this is my final product. Is this item, is this final product a tautology? And probably you say, no, it's not a tautology because there is something that is false. So it's not a tautology. And if it's not a tautology, we just say that it's an invalid argument. Everybody see that? So let me erase all this thing here. Question on my step, question where that I lost you or any questions so far here?
Mr. Tron. Hello?
Yes, yes.
Yeah, I was wondering because on Alex, what kind of throws me off with this particular invalid argument and, you know, tautology or valid arguments, on Alex, it doesn't use the brackets, it uses parentheses for, I guess, to separate where the brackets are supposed to be. So it kind of throws me off.
Then you can just change it on your piece of paper. You can it just basically tell you that it's a different separation. So we have to do the inside and then the outside. Is basically you have to go outside in terms of that. So, you know, one thing is you ask yourself, with the bracket or with the parenthesis, the only reason I use bracket is just to show the difference in terms of a separation, right? I don't want to use the parenthesis right here because you say, wait, what parenthesis is which parenthesis? And that's where it confuses you. But if you look at this item inside whatever the parenthesis or the bracket you have, you ask yourself, what do they try to group? And if you see that this is your parenthesis, let's see, I cannot change it here. If you were to, you treat them as the same, right? You know, for instance,
Okay.
if you were to have this item, if you were to have this item like I cannot change it. If this were to be a parenthesis.
Yeah, I
right?
understand what you're trying to do.
Yeah, if this were to be a parenthesis and not the bracket, you still treat them same. You just basically ask yourself, well, what is my most inner layer? My most inner layer is this parenthesis because I cannot do this operation without knowing what this parenthesis is. So you still work inside your parenthesis and work your way outward. You see what I mean? So even if it's a parenthesis, try not to get the parenthesis distract you, right? Again, and that's why I change it to a bracket to show you the difference in terms of the group, and that's it. It's nothing major in terms of that. Okay.
Okay, thank you.
Any other question? All right. So let's say that if you were to, let me ask you guys to do this thing here. Take a few minutes, see if you can do this on your own. See if we have the P, and we have a Q here. So see if you can translate this 3 item for me and see if this item is a valid or invalid. So I will give you guys 5 to 7 minutes and we will go over this and then we will see. Well, actually, I'm running out of time, huh? We start at 11, right, guys?
Yes, sir.
Well, copy this. Yeah, copy this down and see if you can do this. Copy this down and see if you can do this this problem by yourself. And then we will pick up the first thing on Thursday with this item. And then I will